Today we are going to discuss about limits. Before going to limits, we will discuss some definitions. So now I am taking the sequence X is 2.9, 2.91, 2.92, 2.93, 2.93, 2.94. It will be continuous 2.99. So it will be continuous. It is tending to 3. It is approaches to 3. It is continuous approaches to 3 is called the value of x approaches to 3 from left side. See, here it is a line, it is a 3, here it is a 2.9. So here after 2.9, 2.91, 92, 93, 94, 99, 99, 1992, 992. So here the sequence is approaches to 3 from left side. It is denoted by x is tending to 3 minus. It is called, what is it? Limit extends to x is tending to 3 minus. Here x is equal to 3. It is exactly equal to 3 means x equal to 3. What is the meaning of x is tending to 3 minus? It is from x is approaching from left side from 3. So that maybe it is a near value of the 3 from left side. Next, now I am taking the sequence x is 3.1, 3.99, 3.98, 3.97, 3.961. If you continue like this, here 0, 3.1, 3.099, 3.098, 3.097, like this. If you continue, it is approaches to 3. So is called the value of x approaches to 3 from right side. So here it is a line, it is a 3, it is a 3.1. so here it is approaching from right side. 3. So it is denoted by x is tending to 3 plus. X is tending to 3 plus. That means x is not equal to 3, but it is a more than 3. It is a approaches from 3 from right side. So let me see some more example. Really we can take, if you are taking a 4, if it is approaches from left side means it is x is tending to 4 minus. If it is x is approaching from right side to 4 means x is tending to 4 plus. Next, now I am taking f of x equal to x plus 4. Can you find the f of x at x equal to 3? Yes. That is f of 3. f of 3 is equal to 3 plus 4. That is 3 plus 4 means 7. Now I am taking f of x equal to x square plus 4. Can you find the f of x at x equal to 3? f of x at x equal to 3 means f of 3. That is 3 square plus 4. 3 square means 9 plus 4. 9 plus 4 means 13. So here we can find f of x at x equal to 3, that is f of 3 equal to 13. Now I am taking here f of x equal to like this, x square minus 9 by x minus 3. Can you find f of x at x equal to 3? No, we are unable to find the f of x at x is equal to 3, that is f of 3. If you put x equal to 3, 3 minus 3 becomes 0. So denominator becomes 0. So here the f of x is not defined. So this is for f of x is not defined for x is equal to 3. So we are unable to find f of 3. But we can find the nearest value of the 3. So here that is a limit extends to 3 f of x. We can find limit extends to 3 f of x. Here it is a this is not exactly f of 3, but it is near to the f of 3. So here it is f of 3. We are unable to find the f of 3, but we are able to find the nearest value of the x. So here x is approaches to 3. X is approaches to 3 means it is approaches to from left side, and as well as it is approaches from right side. So what is called x is approaches to from left side? That is called LHL. LHL means left hand limit. What is the LHL? LHL is called left limit. Left hand limit is means what is the value of f of x when x is approaches to 3 a from left side. The value of f of x when x is approaches to a from left side, it is denoted by limit extends to a plus f of x. Limit extends to a plus f of x. Next, what about RHL? RHL is nothing but it is a right hand limit. That is the value of f of x when x approaches to a from right side. So that is denoted by limit extends to a minus. Here it is a minus, it is a plus f of x. So when is the limit exist? Limit exist at x equal to a if limit extends to a plus f of x is equal to limit extends to a minus f of x. So limit exists at x equal to a. So here it should be satisfies left limit is equal to right limit. Next note, limit extends to a f of x equal to L if limit extends to a plus f of x is equal to limit extends to a minus f of x, that is equal to a. In other form, limit extends to a plus f of x, we can take limit extends to 0 plus f of x a plus h. Limit extends to a minus f of x, we can write it as limit extends to 0 minus f of a minus h. Let me see one of the example. Limit extends to 3 x cube minus x square minus 9 by x minus 3. So first of all we have to find LHL. LHL means limit extends to 3 plus f of x, that is x square minus 9 by x minus 3. So that is limit extends to 3 x square minus 9, we can write it as x minus 3 into x plus 3 by x minus 3. So these both will get cancelled, that is equal to limit extends to 3 x plus 3. So that is a 3 plus 3. 3 plus 3 means 6. What about RHL? So limit extends to 3 minus 3. Here it is 3 minus. It is a 3 plus f of x, that is x square minus 9 by x minus 3. So that is the limit extends to 3 x square minus 9, we can write it as x square minus 3 square, a square minus b square, a plus b into a minus b, x minus 3 into x plus 3 by x minus 3. These both will get cancelled, that is the limit extends to 3 x plus 3, 3 plus 3, 3 plus 3 means 6. Therefore LHL is equal to RHL. So therefore limit extends to 3, x square minus 9 by x plus x minus 3 is equal to 6. Now let me see, x is tending to 3 minus means the near values to from left side. So x values I am taking 2.9, 2.91, 2.92, 2.93, 2.94, so on. It is a 2.98, 2.99. These are the x's approaching from left side from 3. So the corresponding f of x. So f of x is x square minus 9 by x minus 3. So that is x minus 3 into x plus 3 by x minus 3. X minus 3, x minus 3 cancel. That is x plus 3. Now 2.9 plus 3. That is 5.9. It is a 5.91, 5.92, 5.93, 5.94. It is a 5.98, 5.99. So it will be continuous. So it is a, when x is approaches to 3, automatically the f of x is approaches to 6. So from this we can say that limit extends to 3 minus f of x is equal to 6. Now I am taking another diagram table. Here x values are 3.1, 3.099, 3.098, 3.097. So it is continuously 3.001, 3.001. So 3.001 like this. So here the f of x value, x plus 3, 3 plus 3.1, 6.1, 6. Here 3, 6.1, 6.099, 6.098, 6.097, swan 6.01, 6.001. So here x is approaches to 3, automatically f of x value is approaches to 6. So this is limit extends to 3 plus f of x is equal to 6. Now by the diagram, here x value, here it is a 3, here it is a 6. So x equal to 0 means here it is a 3. So the diagram will be like this. Here 0, 3. Here it is a 6. So here the value is approaches to from left side to 3. Then the corresponding f of x value is approaches to 6. When you are approaching from right side also this value is approaches to 6 only. So 6 is not there because the function is not defined for exactly x equal to 3. But the function is defined for less than 3 and greater than 3. So here both if it is 3 plus or 3 minus, the function gives the value is 6. So therefore we can say that limit extends to 3, f of x equal to 6. Let me see one more example. Let f of x equal to x square, x equal to x is greater than 1, greater than or equal to 1, x if x is less than 1. So now we have to find the limit extends to 1. So find limit extends to 1 f of x. So here limit extends to 1 plus f of x. So this is nothing but RHL. RHL is equal to limit extends to 1 plus f of x. 1 plus means more than 1. More than 1 means it is defined x is greater than or equal to 1, x is less than 1. So 1 plus means more than 1. So we have to take x square. So limit x tends to 1, x square. So put the value x equal to 1, that is 1 square, that is equal to 1. Now I am taking LHL. LHL means left hand limit. Limit x tends to 1 minus f of x. So here it is a limit x tends to 1. Limit 1 minus. 1 minus means less than 1. Less than 1 means x. So 1. So therefore LHL is equal to RHL. So from this we can say that limit x tends to 1 f of x is equal to 1. Let me see one more example. Let f of x equal to x plus 2, x minus 2. If x is less than or equal to 1, if x is greater than 1. Now let me see, check, find limit x tends to 1 f of x. So first of all, LHL. LHL means limit x tends to 1 plus f of x. So the LHL means 1 minus f of x. Limit x tends to 1. 1 minus means less than 1. So we have to take x plus 2. X plus 2 means 1 plus 2. 1 plus 2 equal to 3. And what about RHL? RHL is equal to limit x tends to 1 plus f of x. So this is a limit x tends to 1. 1 plus means more than 1. More than 1 means x minus 2. So x minus 2. So 1 minus 2. 1 minus 2 is minus 1. In this case, LHL is 3, RHL is minus 1. So they are not equal. So therefore, LHL is not equal to RHL. So therefore, limit x tends to 1 f of x does not exist. Let me see one of the example diagram. Here 0, it is 1, it is 1, it is minus 2, it is a 2. So next from the diagram, it is a given diagram. Now find limit x tends to 0 f of x. So is it exist or not? Verify that. First of all, we have to find limit x tends to, first of all, find limit x tends to 0 f of x and limit x tends to 1 f of x and limit x tends to 2 f of x. Now let me see limit x tends to 0 minus f of x, that is LHL. Limit x tends to 0 minus so what is answer? 0 minus means approaching from left side. So you see approaching to x from left side, the function is approaches to minus 2. So this is minus 2. So therefore it is minus 2. Limit x tends to 0 plus f of x. So x is approaches to from right side, the function is approaches to 0. The function is approaches to 0. So this is a limit x tends to 0, 0. So this is 0. So LHL is not equal to RHL. So therefore limit x tends to 0 f of x does not exist. Does not exist. Next, if we take a limit x tends to 1 plus f of x, limit x tends to 1 plus means more than 1 from right side, the function is approaches to 1 only. So 1, that is equal to 1. Limit x tends to 1 minus f of x. 1 minus f of x means the x is approaching from left side, the function is approaches to 1 only. So limit x tends to 1 is equal to 1. So therefore here limit extends to 1 plus f of x is equal to limit extends to 1 minus f of x. Therefore limit extends to 1, f of x is equal to 1. Next let me see limit extends to 2. Limit extends to 2 plus f of x. 2 plus means more than 2. So here it is approaches from right side. So it is the function is giving minus 2. So limit extends to minus 2, 2 it is gives that minus 2. So answer is minus 2. And limit extends to 2 minus f of x. It is x is approaching from left side of the 2. So the function is gives that 0. So limit extends to 2, that is 0. So answer is 0. Here in this case LHL is 0, RHL is minus 2. So LHL is not equal to RHL. So therefore limit extends to 2, f of x does not exist. Does not exist. Let me see some more examples. The first one, evaluate limit extends to 2 plus x square minus 1 by 2x plus 4. So this is a limit extends to 2 plus x square minus 1 by 2x plus 4. 2 plus means more than 2. It is x is approaches from right side. So we can put directly. So this is 2 square minus 1 by 2 into 2 plus 4. So that is 4 minus 1 by 4 plus 4. So that is 3 by 8. 3 by 8. Next, let me see second problem. Evaluate limit extends to 2 plus step of x minus 2 by log of step of x minus 2. So 2 plus means more than 2. More than 2 means, so here x is approaching to 2 plus, that implies x is approaching to x minus 2. X minus 2 is approaching to 0 plus. So x minus 2 is approaches to 0 plus means the step value will gives that 0 only. Step value gives that 0 only. Then what about log of step x minus 2? It gives that minus infinity. It gives that minus infinity. So here what is the diagram of log x? So it is a diagram of log x. Here 0 plus, if it is x is approaches to 0 plus, the log function gives that minus infinity. So from this the limit value is equal to 0 by minus infinity. 0 by minus infinity gives that 0 only. The next problem, third problem, evaluate limit extends to 1 sine of step of cos x by 1 plus step cos x. So here x is approaches to 1 plus, then what will happen? Cos x value is approaches to 1 minus, because the diagram of the cos x is like this. So here x is approaches to 0 from left side, this value is approaches to 1. So here it is from right side also it is approaches to 1 only. So that means if you are taking x plus x is equal to 1 plus, cos x is tending to 1 minus, near to 1, and x is tending to 1 minus also, cos x value is tending to 1 minus only. So in the both cases, then x is tending to 1 plus, then what will happen? Step of cos x, it is 1 minus. 1 minus means 0.9999 something. So that is equal to, we will get 0. x is tending to 1 minus also cos x step value is equal to 0. So from this, limit extends to 1 plus f of x is equal to, we will get limit extends to 1 f of 1 f of x means sine of, limit extends to 1 plus means this value is equal to exactly 0 by 1 plus 0. So sine 0 exactly 0, 0 by 1 plus 0 equal to 0. Limit extends to 1 minus f of x is equal to limit extends to 1. If 1 is x is tending to 1 minus, then the step of cos x equal to 0. So 0 by 1 plus 0, so that is equal to 0. So therefore limit extends to 1 plus f of x is equal to limit extends to 1 minus f of x is equal to 0. So therefore limit extends to 1 f of x is equal to 0. So that is a limit exists and equal to 0. So next problem, if f of x equal to x minus step x by, x minus mod x by x, if x not equal to 0, 2 if x is equal to 0, show that limit extends to 0, f of x does not exist. So here it is a limit extends to 0 plus mod x, let me see mod x. If it is, let me see like this, x is tending to 0 plus, then mod x value is tending to, x is tending to 0 plus means mod x will gives that plus x. X is tending to 0 minus, then mod x gives that minus x, because the function is defined x is greater than 0, then mod x equal to x. If x is less than 0, then mod x equal to minus x. So x is tending to 0 plus means mod x equal to x. X is tending to 0 minus means mod x is tending to minus x. Let me see limit extends to 0 plus f of x, that is equal to limit extends to 0. Here f of x 0 plus means more than, here it is x is not equal to 0 and x is equal to 0. More than means this one only, less than means this one only, but the mod x will change. Here it is x minus mod x by x. So limit extends to 0. 0 plus means we will get mod x is equal to x by x. X minus x, 0. 0 by x we will get 0. So limit extends to 0 plus f of x equal to 0. Next limit extends to 0 minus f of x, that is equal to limit extends to 0. F of x means x minus mod x by x. 0 minus means mod x equal to minus x. So limit extends to 0, x minus of minus x by x. So we will get limit extends to 0, x plus x by 2. So this is limit extends to 0, 2x by x, x get cancelled, that is equal to 2. So therefore limit extends to 0 plus f of x is not equal to limit extends to 0 minus f of x. Why? It is 0 and it is 2. So limit extends to 0 plus f of x is not equal to limit extends to 0 minus f of x. So therefore limit extends to 0, f of x does not exist. Right.